Hello guys, welcome back. So this is the result. I have almost 50 frames done and it's taking 2 minutes, which is not bad at all, and the resolution is quite reasonable to start with. Now the first few frames here, see, we're getting this stepping effect. That's because the input resolution of the data was low res. These two things are not really related to each other, because as long as there is density coming in and the resolution of the smoke object inside the solver is set to high res, it will make use of that data and create interesting details. Now, if the object is very high res and the smoke object in the solver is low res, you will only get low res data. It's not gonna improve or change. We have to always keep these in sync, preferably at the same resolution, with maybe a little bit of difference, but overall they should be in sync. So what I should have done is linked that volume size in the smoke object to the VDB from polygon resolution, so the incoming resolution matches the sim. And yeah, we have a lot of details. Everything seems to be working as expected. It's emitting for 10 frames and then dissipating, and this is just the ground taking over, and this is all the smoke behavior at the moment. Nothing interesting here. Okay, so let's take it a bit further, and we're going to add velocity to this and change it a bit. So let's clear the cache. And I use the visualization set to 1024 to display the volume at its highest resolution. So let's lower this to maybe let's leave it at 0.2, that's fine. I'm gonna lower this to 0.2 so it's faster to work with. And what I'm going to do, sorry about that, what I'm going to do is I want to create a velocity vector with this, because what we can do is we can feed in extra fields for the source. So we have this will read the density, this will read the temperature coming in from the object, and this will read the velocity. And we can see the binding here. If we go to dot binding, this is what it uses. So if we create a field and name it val for the velocity, we can use it to add variation to this. Okay, let's say height, and let's change this. Looks like I have a black ground somewhere. And let me change the background back to light and show the grid. Okay, so what I'm going to do is I'm going to create a velocity vector for this. And I don't want to create something random. I want to move the smoke in a way that it respects or it inherits the silhouette of this guy. So what I'm going to do is I'm going to create a facet node and make sure I have a normal first to work with. So we have our normal data, you can see it there. I'm going to create a point vol and use the cross product to change this normal so it follows the curvature of the mesh. Let's dive inside. Let's create a cross product of the normals with an up vector. And let's take a look at the result. Cool, so we have this vector at the moment. Let's compute another cross product of this result with the normal itself. So let's first normalize all this data to make sure everything is good. Okay, let's compute the cross product of this with the normals again and see what we get. Also, we get a surface pointing upward, and what I'd like to do is I'm gonna use a noise pattern to mix between the two. Let's create a noise and mix between this and this, and that's going to be my velocity vector, and I don't need it to be in the normals anymore. And let's use this noise here. Let's increase the frequency, actually lower the frequency, and let's increase the amplitude to 2. Sorry. Okay, and I'm gonna use this as the velocity. You can see it's always following the surface and or the surface going to, swirling to in this direction, or going upward, which will create some cool movements. Okay, so inside this VDB from Polygon, now I'm gonna use, sorry, not this. Inside this VDB from Polygon, I'm gonna tick on surface. I'm gonna create a val field by sampling the point.v. I'm gonna also turn on fill density, so we have interior field with 100%. Okay, let's check. Yeah, resolution is good now, and I want to increase the density. It feels very, very low here. I want to increase it before it gets into the solver, and it's always better to have denser data because we can lower the density versus having low density and having to increase them. So we're going to increase that, and we can either use a volume VOP to do that, or we can use a wrangle VOP, a volume wrangle, sorry. And this, we can also write vex code to process the data. So I'm going to say density field is equal to itself multiplied by 10. Now we have increased that. Instead of using this repeated syntax, we can just do this. We can say multiply equal by 10, and that will multiply, will know that we want to multiply the attribute itself with 10. And I'm gonna leave the emission continuous, and to see how it affects, how the noise affects the result. Cool, so you see things are going in different directions. Let's set it to 4. Sorry. Set it to 4. I'm gonna go up, and here I'm going to pin this viewer. Because we can't view the shaded version, sorry, this guy, and if I lock the viewer here, we can, when we dive inside, we're going to be able to see it. So see that it's getting clipped here, so I'm going to add more padding to it. So let's set this to 1. Let's go back, let's hit play, and we have a lot of crazy density, crazy velocity coming in. So let's do this. Let's animate this velocity for maybe from 7 to 0. I only wanted to go crazy in the first few frames, and I'm gonna lower the density. I think it's too strong at the moment, and I want it to be active for 15 frames. So $F is less than 15. Let's hit play. Cool. And yeah, that's pretty much it for the velocity. We can actually increase this maybe to 15. And we can play with the vectors a bit more, maybe. Let's lower this. And maybe let's flip the let's flip the velocity completely. So I'm going to go back to the first frame, and I'm gonna say it's -10. That way it's gonna go in the reverse direction. Cool. So we have some very interesting emission now happening. Okay. Apart from having adding noise here, I'm gonna use a node called gas turbulence. Gas turbulence, and this is like the pop force turbulence, except that it works with volume. So we're gonna merge it with the source. After the source, I'm gonna give it a value of 1. I'm gonna set the swirl size to 2, and let's see how it affects the result. And you can see now we're getting a lot more noise with the sim. And what I like to do is I like to layer a couple of them. So I'm going to set this to 0.5. I'm going to copy it. I'm going to set it to 1. and lower its scale to 0.4, and then do another one that is even smaller. And lower it to 0.6. Let's hit play. Cool, so we have some nice emission. You can see we're getting a lot more details now at the bottom here. Okay, let's do, let me show you guys one more thing. Now, apart from the velocity and density, we can also create a temperature field and pass this to the solver. And with the temperature field, we can use it to cause the smoke to go up and rise, or we can also cause it to go down. We can create buoyancy using this field. So what I'm going to do is I'm going to remove, isolate the density field. At name equal density, and this way we can delete everything except the density called the field called density. I'm going to use a node called name. I'm going to rename this field from density to temperature. Okay, but right now we're copying the density into the temperature. I want to add some randomization to this, so let's find one of those volume VOPs thing. Yeah, so let's copy this. I don't want to use a volume sample, and let's do this processing before, because this node expects the name to be density. So let's do that, and let's add a clamp here in case there is any values or crazy values or anything like that. Let's lower this, and I'm gonna have, maybe let's increase this. Let's copy it and set this to 1, 1, and 1. Something like that. And now we have a temperature field. Density to temperature. And all we have to do is merge this with the original result. And if we take a look, you see now it's the temperature field, density, and val. And I can also use a visibility node and make sure everything here is hidden. So it's visible, now it's hidden. And see, the primitive name is, the temperature is the top one. The reason for that is the merge order. If we flip this, it's going to be the density and val first, and then the rest. So let's move this. And let's import that here. It's already imported, so I'm just gonna set it to 100 so we can see a difference. And let's see what's happening. Sorry, it's the viewport is pinned, so we need to look at this. Okay, I'm not seeing any difference at the moment. Yeah, so 1,000, 10,000, and it's exploding up. And that's because if we go to the smoke solver, we have this buoyancy lift, and what it does is going to read the temperature and create a force that moves the smoke along this direction. And this is a multiplier on top of that, and all this is driven by the temperature field. So right now everything is rising up, which it doesn't look bad. No, I think it's cool. So let's leave this at 5. Let's set this to 100, and let's set the cooling rate to 0.7, because we don't need the pyro solver to create, something that has fire in it. We can just create our own temperature field, and we should be able to do some cool stuff. Let's set this to 400 until we see some rising of the smoke, and then it's going to dissipate and probably fall down. Okay, I think it's too high, so let's try 300. Poor statue. I don't know what we've done, but it looks cool. Okay, let me show you some more stuff. So we have all these guys, and what's happening with the sim right now is there's a lot of data, there's a lot of movement, there's a lot of cool stuff going on, and there is a node to enhance the swirly motion, and it's called gas vortex confinement. And this takes the sim and simply improves the overall motion of it. I'm going to set this to 4. I always have one of these nodes in the sim. And let me go over, actually I remember that I didn't go over these things because I'm not going to use all the features. Actually, there's not so much. These things are for driving the temperature. We can diffuse the field so it dissipates and gets blurrier over time. This is the cooling rate for the temperature field. This is the thing that moves it upward. Viscosity, this is for making the fluid feels viscous, which we're not going to do at the moment. These are, we're not going to need, you don't need to change anything here as long as we are not merging anything or adding, we don't have to worry about this at the moment, trust me. This is the important part. If we have a fast-moving object or we need to add sub-steps to the sim, this is where we do it. And then we're going to leave everything else as the default at the moment. Now, let's sim few frames. Okay, cool. See, it's already changing. And I'm going to look at the result using this node. Let's turn off the max vis resolution, and I'm gonna use this emission feature to display the temperature to you guys. So here, well, because we're not importing it in the dot field, so we're not gonna have access to that. We have to tick this option, tick this box to tell it to import the temperature field. Now it's gonna become available. I'm gonna set it in both sections, and I'd like to set these guys to be linked, so that if the temperature field is going between 0 to 500, we can remap it. And what I'd like to do is I'm going to use something called black body to set these colors, and I'm going to change them to look a bit more interesting. So let's do this, and let's remove the green from here. Move this guy, and it's showing up. We can take a look at it without the lights. And let's increase it 100 times, and now it's super bright. So let's fix the range because I think there is a lot of data is just not visible. Yep. And that's our temperature field, this guy that we've made. And you can see it here in the first frames, and then quickly it's getting affected by the sim, and then the emission stops and everything else. Cool, so let's set this to, I think 100 is cool, maybe even 1000. And this is just for the viewport, by the way. Okay, so what else? We added temperature. Now, let's say we want to visualize this data in here. Let me unpin this so we see the data in DOPS. And under the smoke object, if we look at the visualization features, it says density right now. I'm going to turn this off and tick on multi-field, and now we have access to the same controls that we did in SOPs. So I'm going to say the density field is called density. Okay, and I'm going to go to the emission, set this to 1. This is called temperature. Same name. Do the same thing here. Copy, paste relative. I think 300 we did, and this is 100. I'm going to change this color to have more saturated tone. Move this here. I'm going to remove some green from that color. Okay, and now we have the same viewport, except the lighting, we can only get that from at the SOP level. So if we hit play, you can see we have temperature field, and we have the smoke rising. So this is what I'm going to do. I'm going to copy this division size and go up and make sure that my VDB has the same resolution. Okay, I'm going to increase this a bit in case, what it does is, in case there is data on the boundaries, we added a couple more voxels to it. Before it was 3, so we added 6, and that will add some more surrounding information in case we needed to multiply the density. So we linked those two. Let's set this to 0.08. Everything else is the default. And let's display this. I'm going to change the viewport to black. Hide the thing. Hit play. Let's see where the statue is at. Okay, cool. So let's move this to frame it better. And right click. And let's see how it looks at this resolution. Obviously, I'm not gonna wait for the sim to finish. We'll do like 20 or 30 or 40, 50 frames, and we'll continue in the next video. Thank you guys for watching, and see you in a bit.